In this video, we're looking to evaluate the composite of two functions. It's going to be a trig function and an inverse trig function. So we're asked to find the exact value of the tangent of the inverse sine of 1/2. Now, when you're given a composite function, you always want to work from the inside out. So you're basically just going to evaluate the inverse sine of 1/2. Whatever this gives you, you're going to then evaluate the tangent of that. So if you recall, the inverse sine is going to give us some angle measure theta, and the inverse sine is restricted to quadrants 1 and quadrant 4, and so we have to figure out which quadrant is this going to be in. Now, because the value of the argument of our inverse sine is positive, that tells us that we are going to get an angle in quadrant 1. The output of this is going to be an angle in quadrant 1. So if you think about the inverse sine of 1/2, what angle, so remember this just means what angle gives me the sine of theta equaling 1/2? Well, this happens when the y coordinate is 1/2, and that's with the ordered pairs rad 3 over 2, comma 1/2. This happens at theta equaling pi over 6. So when theta is pi over 6, we get a sine of 1/2 in quadrant 1. So now we're going to evaluate the tangent. We're going to evaluate the tangent of pi over 6 because the inverse sine of 1/2 is just pi over 6. So the tangent of pi over 6, well, we know that that's just the y coordinate divided by the x coordinate, and these are the coordinates for the pi over 6. So that's going to be 1/2 divided by the square root of 3 over 2. And we're going to keep the numerator and multiply by the reciprocal of the denominator. So 1/2 times 2 over rad 3. Those will cancel, and we get 1 over the square root of 3. Rationalize by multiplying top and bottom by the square root of 3. And we get rad 3 over 3. Rad 3 over 3. So the tangent of the inverse sine of 1/2 is equal to the square root of 3 over 3. So that is this value here. For this next example, we want to find the sine of the inverse cosine of negative 1/3. Now, in the last example, the value that we had on the inside was one that we knew from the unit circle. However, negative 1/3, we don't know the angle measure. It's not a special angle that gives us a cosine of negative 1/3. So what does that mean? That means we're going to have to refer to the unit circle. So first, because this is an inverse cosine and the argument is negative, that tells us that we're going to be, its output is going to be an angle in quadrant 2. So let's draw a triangle in quadrant 2. So we have quadrant 2 here, drawing a triangle here like this. Note that this triangle is not drawn to scale. It's the cosine, so here's theta. Theta's here. The cosine is the adjacent side over the hypotenuse. So this side length is 1, the hypotenuse length is 3. And so we need to find the missing side so that we can then evaluate the sine. So we know that this value here, inverse cosine of negative 1/3, it's just going to give us the value theta, which is going to be this angle measure here. But we don't actually need to know what the angle is. We just kind of need to draw a triangle so that we can then use this triangle to find the sine. So again, we know that that measure is negative because the x is in the negative direction. So let's find the last side. So this is 3 squared equals 1 squared plus b squared. So 9 equals 1 plus b squared. So b squared is equal to 8. Take the square root, and we get that b equals the square root of 8, which is 2 rad 2. So this value here is 2 rad 2, which we know should actually be larger than 1. But again, like I said, this triangle is not drawn to scale. So now we're trying to evaluate the sine of theta, right? We're trying to evaluate the sine of theta, where theta is just the measure in this triangle. In quadrant 2, we know that the sine is positive. So in quadrant 2, the sine of theta is positive. So we can just evaluate this. The sine is the opposite side over the hypotenuse. So this is going to be 2 rad 2 over 3. That's what the sine of theta is going to equal. So in the end, the sine of the inverse cosine of negative 1/3 is going to be 2 rad 2 over 3. So this is the value of that measure there.